This is section 4.2. The largest number that divides evenly into two or more integers is called their greatest common factor, GCF. So if I'm looking for the greatest common factor, and if I don't immediately recognize it's 25, one of the things I can do is take the prime factorizations of these numbers and I'm going to write 75 as 5 times 5 times 3, and 25 is 5 times 5. And then I see that I have a common factor of 5 and another common factor of 5. So the greatest common factor is 25. This is 25 times 3 over 25. So that's my GCF, and that's how I can use prime factorization to find it. Simplify this fraction, recognize that it's negative, so make sure your simplified fraction is also negative. So I'm going to take 12 and break that down to 6 times 2. So I have 2 times 2 times 3, and 60 is 15 times 4. That's 3 times 5 and 2 times 2. So I have 2 times 2 times 3 times 5. Now, when you divide out common factors, 2 divided by 2 is 1, 2 divided by 2 is 1, 3 divided by 3 is 1. Be careful, if it appears everything is canceling out of the numerator, it's not. There is a 1 there. And this is negative 1/5. And you can put the negative sign with the numerator or just out to the side. Negative 1/5. Okay, we can simplify fractions by reducing out common factors of 10, 100, or 1000. So I can rewrite 170 as 17 times 10. And 30 is 3 times 10. And the 10s cancel. It's the same as canceling a 0 off of each of those numbers. And we see that 17/3 is my reduced fraction. So as long as I'm canceling the same number of zeros, I'm dividing by 1, and I'm not changing any values. So I can take zeros off the end on 2 of these, and I end up with 25 over 750. And that's going to make it a little bit easier to reduce, and then I can reduce any way I want. I can recognize that 25 is a factor of 750, and that's going to simplify to 1/30. Now, sometimes we have to reduce fractions that contain variables. So I'll write 10 as 2 times 5. Then I have x times y. And in my denominator, 6 is 2 times 3 times x. So the 2's cancel and the x cancels, leaving me with 5y divided by 3. Here I have 2, and a to the 3rd power is a times a times a. In the denominator, I'm going to rewrite 4 as 2 times 2, and a to the 4th power. So 2 divided by 2 cancels to 1, a divided by a divided by a divided by a. So it seems like everything's canceled from the numerator, but we need the 1 there to hold the place so that we know that the 2a is in the denominator. Madeline got 28 out of 35 problems correct on an algebra exam. David got 27 out of 45 correct on a different algebra exam. What fractional part of the exam did each student answer correctly? So if Madeline got 28 out of 35, we can reduce that to 4/5. And David got 27 out of 45, and we can divide out common factors and reduce that to 3/5. So which student performed better? So if we compare 4/5 to 3/5, we see that Madeline performed better. Here's practice problems for you to try on paper.